what I can in the notebook, but if I realize that it's going to take too much space, I'm going to write it in. I'm going to write it somewhere else. So example 1, they give us this rational expression, and what they want us to do is they want us to basically factor it. They want us to simplify it. So I start by labeling what my numerator is. I'm going to rewrite that numerator, which is 3x to the 5th.
Wait, who took
100.
Who took that pencil? Somebody took the pencil.
Minus 18x to the 4th minus 21x cubed. And what we have to do is we have to factor the numerator, and eventually we're going to factor our denominator too, so if you want to go ahead and write it. Alright, I know I can take out x to the 3rd, but I can also take out a 3 because they are all a multiple of 3. So 3x to the 3rd leaves me with x squared minus 6x minus 7. So I divided 3 by 3, negative 18 by 3, and negative 21 by 3. Now what I need to do is I need to factor what's in parentheses. So I need two numbers that will multiply to give me a negative 7, but add together to give me a negative 6. Well, there's only two factors of 7, and that's 7 and 1. But how could I write these signs so that they became, so added together they were negative 6? Any idea? It would be minus 7 plus 1. So now what we have done is we have factored this numerator. Now we need to factor our denominator. For my denominator here, I know I can factor out a 2x to the 4th. Well, how do I know that? Because they are both even numbers and the smallest exponent is x to the 4th. That leaves me with x squared minus, 98 divided by 2 is 49. So minus 49. When I see x squared minus 49, I know that's the difference of squares. What's the square root of 49? 7. So this becomes x plus 7 times x minus 7. Alright, so what we have done so far, we have factored our numerator, we have factored our denominator, okay? It tells you, it says, remember to give a domain for your expression. Your domain for your expression is going to include something I'm going to call EV. Well, what is EV? EV is excluded values. Well, how do you find those excluded values? You take your denominator only, and you set each factor equal to 0. Why do we do that? Because our denominator cannot equal 0. So for our excluded values, (2x to the 4th equals 0, x plus 7 equals 0, and x minus 7 equals 0. So do y'all see how I took each individual factor and set it equal to 0? Solve for x. So this would be x to the 4th equals 0, or x equals 0. And really we say x cannot equal 0. Well, why do we say that? Because those are excluded values. And guys, if they're excluded, that means that they are not, you can't use these values. So this is going to say x cannot equal -7 and x cannot equal +7. I'm going to come back to these. I don't need to forget them. But we still don't have an answer. How do we get an answer? Well, A&S, y'all know what that stands for, right? Answer. I'm going to rewrite my numerator. 3x to the third x minus 7 times x plus 1 over my denominator that I factored out, 2x to the fourth times x plus 7 times x minus 7. So now what we can do is we can cross out anything that is alike on the top and on the bottom. Do we see anything that's on the top that's also on the bottom? What about this? Are these the same? X minus 7. This is x to the third power. This is x to the fourth power. We can cross out this x to the third power. So if I'm getting rid of 3 of these, this just becomes x to the first, right? So now my final answer is going to be 3 times x plus 1. Does everybody know where I got that from? That's what's left over in my numerator, okay? And what's left in my denominator is 2x times x plus 7. X cannot equal, what do we say x cannot equal? Over here, we come back to those excluded values. 0, -7, and 7. So it is a lot of work for one problem, but it's not too bad. All right, below this, I went ahead and crossed out this habits of mind. Yeah, hold on just a second. Okay. I crossed out this habits of mind, and I'm going to write B right here so that I can use this whole top space for A, okay? X to the third plus 4x squared minus x minus 4. Actually, no, we're not. No, I'm not. Me and Miss Jordan yesterday decided we were going to skip B completely. I forgot about that. All right, back to the top. Got it, Mason? Alright, so again, I'm going to factor my numerator. Start by that. X squared plus 2x plus 1. There's only 2 numbers that will multiply to give me 1, and that's 1 and 1. Factor my denominator. First, I'm going to factor out an x. Then I'm going to be left with x squared minus 2x minus 3. My only factors for 3 are 3 and 1. It's going to be minus 3 plus 1. Now remember, for your excluded values, where does that come from? Your numerator or your denominator? Always your denominator. If you want to write yourself a note up here, always come from denominator. So x is going to equal 0, or x cannot equal 0. x minus 3 equals 0, and x plus 1 equals 0. X cannot equal 3, and x cannot equal negative 1. So for my answer, I'm going to write my numerator in factored form over my denominator in factored form. I'm going to simplify where I can. Do you see how there's two x plus 1's in the numerator, right? But I only have one of them in the denominator, so that means we can only cross out one of them, okay? So now my final answer is x plus 1 over x times x minus 3, and then include those excluded values. Alright, this next part is where I started using my paper. So this is 3A. And our directions said find the simplified form of each product and give the domain. So I've got x squared minus 16 over 9 minus x times x squared plus x minus 90 over x squared plus 14x plus 40. Alright, I'm going to write this as numerator 1. This is going to be numerator 1. It's x squared minus 16. Well, that's the difference of squares, I notice again. So what's the square root of 16? 4. So this is x plus 4 times x minus 4. X, oops, that's supposed to be x squared, not x sub x. Next, I've got numerator number 2, where we're going to have x squared plus x minus 90. That's going to be x plus 10 times x minus 9. Alright, I'm going to have denominator 1, which is 9 minus x. So if I rewrite it as negative x plus 9, but what they're going to want you to do is factor out a negative 1. So if I factor out a negative 1, that leaves me with x minus 9. And then denominator 2, x squared plus 14x plus 40 is going to factor into x plus 10 times x plus 4. Alright, so all I've done so far is factor each numerator and each denominator. Now we found our excluded values, and where do those excluded values come from again? Denominator. So any factor with an x we set equal to 0. X minus 9 equals 0, x plus 10 equals 0, and x plus 4 equals 0. So x cannot equal 9, x cannot equal negative 10, and x cannot equal negative 4. So I'm going to actually come up here and write it all as one big fraction. I've got my factors for numerator 1, numerator 2. Do y'all see how I'm just writing it as one big fraction? Denominator 1 and denominator 2. X minus 9 cancels out. Anything else do y'all see can cancel out? X plus 10 and x plus 4. So that leaves me with x minus 4 divided by negative 1, which is going to be negative 1 times x minus 4, where x cannot equal, come back to my excluded values, 9, negative 10, or negative 4. So, you go back to your book. Do you now see why I didn't work that problem in the book? But I am going to write my answer there, which was negative x minus 4, where x cannot equal 9, negative 10, or negative 4. I just wrote my answer there. All right, now we're going to work 3B on notebook paper as well. All right, that one is x plus 3 over 4x times 3x minus 18 over 6x plus 18 times x squared over 4x plus 12. All right, I'm just actually going to start with this one just because it's small. Do you see how it's not quadratic? So there's a lot that doesn't have to be, or it'll be a little easier for us to factor if we need to factor. But I'm just going to rewrite this as one big numerator. So I'm going to look at everything in my numerator first. So I got x plus 3 times 3x minus 18. Do 3 and 18 have anything in common? A 3, right? If I factor out a 3, I'd be left with x minus 18 divided by 3 is 6 times x squared. There's nothing to factor there. That's my numerators. Now I'm going to work on my denominators. 4x, nothing to factor there. 6 and 18, do they have anything in common? A 6, right? Factor out a 6, and I'm left with x plus 3. 4 and 12 have a 4 in common. So I'll factor out a 4 and be left with x plus 3. One more week? 2 more weeks?
Yeah.
Alright, so I'm going to cross out anything I can. I got this x plus 3 and x plus 3. So that looks to me like that's all I can factor out. So I've got 3 times x minus 6 times x squared. I can write that as 3x squared times x minus 6. In my denominator, though, I've got 4x times 6 times 4. So 4 times 6 times 4 is 96. So that's going to leave me with 96x. And then I've got my x plus 3. Well, now I see something else I can factor out, or I can get rid of. I can cross out this x right here. I can cross out this x squared and make it just x to the first. 3 divided by 96. Y'all see it simplified to 1 over 32? So that simplifies to 1. That simplifies to 32. 1 times x to the first is just x. X minus 6 over 32 times x plus 3. I just realized one important thing that I forgot to do. Nope. Those excluded values, where do they come from? Denominator. So anything with an x, I set equal to 0. 4x equals 0. X plus 3 equals 0. Alright, so do you see how I already have an x plus 3? We don't have to write it twice. There's no sense in that. So x cannot equal 0, and x cannot equal negative 3. Brenda, did you think it was going to snow today? Alright, so I'm going to go back to my book and write the answer in my book. X times x minus 6 over 32 times x plus 3. X cannot equal 0 or negative 3. Alright. Example 4 says, find the simplified form of each product and the domain. So same thing that we were just doing, except for just a little bit more factoring on this one. So 4a, I've got x cubed minus 4x over 6x squared minus 13x minus 5 times 2x cubed minus 3x squared minus 5x.
Did you watch the news last night or the day? So I don't know what happened. Because I was reading my Facebook about this last night. And there was a man laying in the rain. And then it was like he either got hit by a car or got shot because he hurt his stomach. And then they had cops block the entire road off. And then my mom was saying that she turned around 4 times and passed him.
Alright, so I factor out an x first. I notice this is the difference of squares, so it factors into x minus 2 times x plus 2. Then I've got 2x cubed minus 3x squared minus 5x. Which is 2x squared minus 3x minus 5. You could use bottoms up, or I know some of you are comfortable with using the snowflake method. A times C is negative 10. Huh? Where you multiply this times this. We talked about it earlier.
I don't want to do that song.
Alright, so two numbers that will multiply, I'll put 2x, 2x. Two numbers that will multiply to give me negative 10, but add to give me a negative 3 would be negative 5 and 2. 2 over 2 simplifies to 1 though, right? So this would be x over 1, or x plus 1. So my two factors are x times 2x, see 2x minus 5, and then x plus 1. Alright, now for my denominator. 6x squared minus 13x minus 5. I'm going to do it the same over here. Something to multiply to give me a negative 30 and add to give me negative 13. 6x, 6x. That's going to be negative 15 and 2. 6 over 2 simplifies to 3 over 1. 3x over 1. 6x over 15, or over negative 15, excuse me. Let's see, we can take out a 3. 6 divided by 3 is 2. Negative 15 divided by 3 is a negative 5. So 2x minus 5. 2x minus 5 times 3x plus 1. Alright, so that's my denominator. I've factored my numerators. I've factored my one denominator here, okay? Now we have to find our excluded values, but luckily we only have two factors. So 2x equals 5. X cannot equal 5 over 2. 3x equals negative 1, or x cannot equal negative 1 over 3. Gotta come back to these here in a minute. So let's write our two numerators. X times x minus 2 times x plus 2 times x, 2x minus 5 times x plus 1. A lot to write, over my small denominator, 2x minus 5 times 3x plus 1. Alright. Only thing I can cross out is the 2x minus 5. So guys, my final answer is x times x minus 2, x plus 2. I've got another x right here, so I'm going to make this x squared times x plus 1 over 3x plus 1. X cannot equal 5 over 2 or negative 1 over 3. So, if you look at your textbook, we definitely did not have room to work that problem right there in the workbook. So, I'm just going to write my answer. X squared times x minus 2, x plus 2, x plus 1. Alright, 4b. Got 3x squared plus 6x over x squared minus 49 times x squared plus 9x plus 14. Alright, so again, factor the numerators, we'll factor the denominator. Numerator, I've got 3x plus 6x, or 3x squared plus 6x. Factor out of 3x, and I'm left with x plus 2. Numerator 2, x squared plus 9x plus 14. It's going to factor into x plus 7 times x plus 2. My denominator, x squared minus 49, that's that difference of squares, so that's x plus 7 times x minus 7. So we find our excluded values. X equals negative, or x cannot equal negative 7, and x cannot equal positive 7. Alright, so now I'm going to write this as one big fraction. Numerator 1, numerator 2, over my denominator. Cancel, cancel. I've got 3x times x plus 2 times x plus 2. So I could just write it as x plus 2 what? Squared. Over x minus 7. X does not equal negative 7 or 7. Alright, so I'll write that answer up here. 3x times x plus 2 squared over x minus 7. X cannot equal negative 7 or 7. Alright. Find the simplified quotient and the domain of each expression. But look what we're doing now. Division, right? Y'all remember when we divide fractions? Did y'all ever use the acronym? I think it was KFC. Keep, flip, change. Where you keep the first one the same, you flip the second one, and what does the change stand for? Change it to multiplication, right? So, 5a. We keep the first one the same, 1 over x squared plus 9x. We flip the second one, so it now becomes 3x squared minus 18x over 6 minus x. And we change the sign to multiplication. So we're going to do the same thing here. We're going to factor. So my numerator 1, there's nothing to factor. Numerator 2, I've got 3x squared minus 18x. Factor out a 3x. And I'm left with x minus 6. For my denominators, I've got x squared plus 9x equals, oops, I didn't mean to put it equals. I was getting ahead of myself. Alright, they have an x in common, so I can factor out an x. Denominator 2 is 6 minus x. We're going to rewrite this as negative x plus 6 and factor out a negative 1. Give me x minus 6. Rewrite it. I've got 3x times x minus 6 in my numerator over x times x plus 9 times negative 1 times x minus 6. But I can't forget those excluded values. X cannot equal 0. X plus 9 cannot equals 0, so x cannot equal negative 9. And then I've got x minus 6, where x cannot equal 6. Cancel out, cancel out. Look, we got x's too. I can cancel those out. So now I'm just left with 3 is in my numerator. Negative 1 times x minus 9, so we can just say negative x plus 9. X cannot equal 0, negative 9, or 6. Alright, 5b. Again, is a division problem, so we keep the first one the same. 2x squared minus 12x over x plus 5. Change the sign and flip the second one to x plus 5 over x minus 6. So the only thing we will actually have to factor will be this numerator 1. So technically we could go ahead and just write it as one big numerator. 2x squared minus 12x, I would factor out a 2x. So I'm left with x minus 6, and then x plus 5. We still have to find those excluded values though. X plus 5 equals 0. X minus 6 equals 0. X cannot equal negative 5, and x cannot equal 6. Cross out what I can, and I'm left with 2x, where x cannot equal negative 5 or 6. So I came back, I just realized I didn't write my answer for 5A in my notes, so I'm going to write both of these answers. I'll just write both the answers right here in my notes. That's all we're going to do today for 4-3. Now we're going to move on to 4-4. So what I did in my notebook, just so you can kind of see, you see this sheet of paper right here? I just stuck it in the middle. That way it's just there in my notes for me. Yeah, right here. What page? What page in the workbook? This one? What about it? This is example 4. Like I just wrote my answers in the notebook. All right, and I'm gonna do the same thing for let's see. All right, so we're gonna try to at least work page 104 today.
So y'all went to school?
And then do 105.
Y'all went to school and went down
I had to go to the bank. So we're going to work examples 1 through 3 today, and tomorrow we'll finish up examples 4 through 6 and finish lesson 4-5. And then Wednesday we'll review for your exam that's on Thursday.
How many questions?
I don't know yet.
How you know?
All right. So we are talking about in this lesson. We just got finished multiplying and dividing. This lesson we're going to add and subtract. But you know, to add and subtract fractions, you have to always have the same denominators, right? You have to have like denominators. So first one's very easy for us because they already have those like denominators, don't they? So I'm just going to combine these. 10x minus 5 plus 8 minus 4x over my like denominator, which is 2x plus 3. I add together my like terms. 10x minus 4x is 6x. Negative 5 plus 8 is a positive 3 over 2x plus 3. And what I would do here is I would factor out a 3 to give me 2x plus 1 over 2x plus 3. I do that to make sure that I do not have, I can't cancel anything out. So that would be my answer for 1A. 104. All right, 1B, x minus 5 They already have like denominators, correct? So x minus 5 plus 3x minus 21 over 2, not 2x, x plus 5. 1x plus 3x is 4x. Negative 5 minus 21 would be a negative 26 over x plus 5, and I would factor out a 2 to give me 2x minus 13 over x plus 5. Nothing can be simplified there, so this would be my final answer. All right, 2a. They're just wanting us to find the least common multiple for each set of expressions so that we can get used to finding my common denominator. So, the two expressions they give you are x plus 2 squared and x squared plus 5x plus 6. So let's think about this. If I've got x plus 2 squared, what does that really tell me? It's multiplied how many times? Twice. So it would be x plus 2 times x plus 2, right? So then, if I've got x squared, I meant to write that, x squared plus 5x plus 6. This would factor into x plus 2 times x plus 3. So least common multiple. What in the world does that mean? That means I need everything that this equation has to be over here, and everything that this equation has to be over here. So let's see. X plus 2 times x plus 2. I know I at least need that. And then I also, so I've got my two x plus 2's that I needed right there. But over here I just need one x plus 2, but what else do I need? I need an x plus 3. So that means I also have to add in an x plus 3. So look, we've got what we needed from the left or the right side, and now I've got what I needed from the right side or the left side too, right? So x plus 2 times x plus 2, we can write as x plus 2 squared plus or times x plus 3. And I think it'll make a whole lot more sense when you actually see it in fraction form as opposed to looking at it like this. Alright, this next one's got 3 of them. We've got 10x squared minus 10y squared. I've got 15x squared minus 30xy plus 15y squared. X squared plus 3xy plus 2y squared. Alright, I am going to just factor these for you to make it a little bit easier. So I'll take out a 10. I've got x squared minus y squared, which is x plus y times x minus y. Right here, I take out a 15 first, and I got x squared minus 2xy plus y squared, which is the same as x minus y times x minus y. And then right here, my factors would be x plus y times x plus 2y. All right, because we have coefficients, we have to look at what our least common multiple would be between these two coefficients. So let's think about 10. 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, right? 15 times 1 is 15, 15 times 2 is 30. So 30 would be my least common multiple, okay? All right, I know I'm going to at least need one xy and one x minus y. But over here, it tells me they need two x minus y's, don't they? So I'm going to write another x minus y so that we can have two of them. And then over here, we've already got our 1x plus y, don't we? But I also need x plus 2y. So I'm going to simplify that to 30 times x plus y times x minus y squared times x plus 2y. All right, two more examples and then we'll be done for the day. All right, so we have to start by factoring if need be. So, does my numerator, my first numerator, does it need factored? No, because it's just a linear term, right? But my denominator, x squared minus 4, factors into x plus 2 times x minus 2. They like using those difference of squares. All right, my second numerator, can it factor anyway? No. But the denominator factors into x minus 2 times x minus 3. So let's take a look at our denominators. Let's just focus on them for a minute. What does the first denominator have that denominator 2 does not have? An x plus 2. So what does that mean? It means I have to multiply the numerator and the denominator by x plus 2, okay? Well, what does denominator 2 have that this one doesn't have? An x minus 3. So I'm going to multiply this equation by x minus 3. So now we get to simplify some things. X times x is x squared. X times negative 3 is a negative 3x. 6 times x is a positive 6x. 6 times negative 3 is a negative 18. 2 times x is a positive 2x. 2 times 2 is a positive 4. I leave my denominator in factored form. I'm not worried about simplifying it just yet, okay? X squared minus 3x plus 6x minus 18 came from FOILing right here. The 2x plus 4 came from distributing the x or the 2 right there, okay? Now we combine our like terms if we can. X squared Nothing else to be combined with them. Negative 3 plus 2x is a negative, oh wait, I forgot the 6, didn't I? So negative 3 plus 6 is a positive 3. Plus 2 is a positive 5. Negative 18 plus 4 is a negative 14. X plus 2, x minus 2, x minus 3. Now we have to factor the numerator. Those two factors are going to be x plus 7 times x minus 2. And guess what? We've got something we can cancel out, don't we? Cancel out the x minus 2. So my final answer is x plus 7 over x plus 2 times x minus 3. Alright, we'll do one more problem and be finished for the day, okay? (3b), and it won't take near as long as the other one did. There's nothing to factor for 2x, nothing to factor for 3x plus 4. But there is two things to factor for the next part. 4x squared minus 11x minus 12. I'm going to use that snowflake method again just to help me out. 4x, negative 12. But we'll add to give, or multiply to give me negative 12, but add to give me negative 11. Oh, that shouldn't have been negative 12. That should have actually been 4 times negative 12, which is a negative 48. And guess what? It cannot be factored. So we actually have to leave it the same. 4x squared minus 11x minus 12. Let's see if the bottom can be factored. Need something that will multiply to give me a negative 24. But add to give me a positive 5. And that was 8 and negative 3. This simplifies to 2x over negative 1. And this simplified to 3x over 4. So that means my two factors are 3x plus 4 times 2x minus 1. What do I need to add to this denominator so that they are alike? Yep. I'm going to multiply by 2x minus 1 and 2x minus 1. 2x times 2x is 4x squared. 2x times negative 1 is a negative 2x. And then we got our plus 4x squared minus 11x minus 12. All of that over 3x plus 4 times 2x minus 1. Combine your like terms. 8x squared minus 13x minus 12 over 3x plus 4 times 2x minus 1. And I'm going to see if it can factor. I don't think it can. Negative 96, negative 13, 8x, 8x. Nope, it can't be factored, so this has to be our answer, okay? Alright, we will stop there for today. We'll pick up these next 3 examples tomorrow. And also the next chapter. The next lesson tomorrow.